Let's take a look at this problem. We want to find the absolute extrema of this function on the closed interval. So we've got f of x is equal to x squared minus 9 to the 4/3 power on the interval -4 to 2. Well, first thing we need to do is find our derivative. This is a chain rule, specifically a general power rule. You got parentheses to a power, take your power, put it out in front. So we got 4/3. What's inside the parentheses remains as is. Lower your power by 1. So we got 4/3 minus 1 times the derivative of what's inside the parentheses. So that gives us 4/3 x squared minus 9. 4/3 minus 1 gives us 1/3. And derivative of x squared minus 9 is 2x. Now, I'm put the 2x out in front, so we got 4/3 times 2x times x squared minus 9 to the 1/3. 4 times 2 is 8, so we got 8/3 x, and x squared minus 9 to the 1/3 power. Okay, now we want to set that equal to 0. So we got 8/3 x times x squared minus 9 to the 1/3 power is equal to 0. Now, zero factor property. If you get 0 on one side, you factor to the other side, you can set each factor equal to 0. So we get 8/3 x is equal to 0, and x squared minus 9 to the 1/3 power is equal to 0. Now, if you got a number out in front here, you can just drop the number if you got 0 on this side. Why? Well, if you divide both sides by 8/3, this would disappear, and 0 divided by anything is 0. So you get x equals 0. Now over here, if you have parentheses to a power, you can just drop the power, assuming you have it set equal to 0. So we're going to have x squared minus 9 equal to 0. Square root property, I'm going to take the -9 to the right side, becomes a +9. Square root property says if you got something squared equal to something else, you drop your squared, and you put a plus or minus square root around the other side. And square root of 9 gives us 3. So we get x equals 0, x is equal to -3, and x is equal to +3. Now, we only want to keep the critical values that's in our range of values given. They're telling us to look between -4 and 2. Well, 0's okay. That's between -4 and 2. -3, that's okay. That's between -4 and 2. +3, though, that's not okay. That's greater than 2. So these are only two critical values we'll keep. So we're going to plug in x is equal to 0. We'll plug in x is equal to -3, and then we're going to plug in our endpoints. So plug in x is equal to -4, and x is equal to +2. Now, when I say plug it in, I'm talking about plugging it into our original function. Remember, f of x is y, so we're going to plug it into here. I didn't leave hardly enough room. First thing I'm going to do is I'm going to plug them into the calculator. Now, that's going to give us some decimal approximation. Then I'll go back and find the exact value. Okay, so come over here. I'll press y equals. Press clear. We got beginning parentheses x squared minus 9, closing parentheses caret, and since I have more than a single number or a single variable up in our exponent, I want to put parentheses on it. So I'll put a beginning parentheses, 4 divided by 3, closing parentheses. Now I want to make sure my table setup is correct, so I'll do second window, and where it says independent, it should say ask. If it doesn't say ask, down arrow to it, right arrow, put your flashing cursor on the ask and press enter. Now we want to go in table, so I do second graph, and I'll press delete a few times. And we'll put in 0, enter, -3, enter, -4, enter, and 2, enter. Okay, so we got this one's 18.7. This one is 0. This one is 13.4. This last one is 8.5. Okay, our smallest y, which is the 0, is going to be absolute min. So we're going to have an absolute min of -3, 0. Now that's an exact value, so we're happy at that answer. Our largest y value, which is the 18.7, that's going to be our absolute max. But that's an approximation. Let's actually plug in our x equals 0 into our original function and see what we get. Here's our original function, f of x is equal to this, so I'm going to put y in for the f of x is equal to, I'm putting 0 in for x, so I got 0 squared minus 9 to the 4/3 power. Okay, so 0 squared is 0, that drops away. So we got -9 to the 4/3 power. Now I'm going to rewrite this in the radical form. So this says, and well, first let me rewrite this as -9 to the 1/3 power, then raised to the 4th power. If you got a fractional power out in front here, a rational exponent, you can take the number up on top, the numerator, put it on the outside of the parentheses like that. So then this becomes the, actually, I think I'll do it another way. Never mind. You could do it that way, but there's a simpler way. I'm going to put the 4 on the inside. So we're going to have -9 to the 4th, all that raised to the 1/3 power. Well, the reason why I decided to do this way is because if I take it to the 4th power, any negative number to an even power always becomes positive. So I can drop that negative. And the 1/3 power is a cube root. So again, it's a little bit easier this way. And then this becomes 9 to the 4th. Now again, I drop the negative because when you take it to an even power, your negative number always becomes positive. Now 9 to the 4th, that means I got 4 9s. Our index is 3. The index is numbered in a slot right here, which means we're looking for a set of 3 of something. Well, here's 3 9s, so the 3 9s are going to come out in front as a single 9. So we have 9 cube root of 9. So our absolute max is going to be 0, 9 cube root of 9. And that combined with our absolute min here are our answers.